What makes trapezoid area formulas seem so complex? Imagine trying to measure a shape that looks like a stretched-out ladder with one side longer than the other. It might seem simple at first, but the math behind it can look confusing. That's because trapezoids are different from other shapes like rectangles or squares. Those shapes have sides that are all equal or right angles, making their area formulas straightforward. But a trapezoid has one pair of sides that are parallel, called bases, and the other sides, called legs, can be slanted or uneven. This makes calculating the area a little trickier. The main reason the formula seems complicated is because it combines two ideas: the lengths of the two bases and the height, which is the distance between those bases. The formula is written as half of the sum of the two bases multiplied by the height. So, you add the lengths of the bases, then take half of that total, and finally multiply by the height. It's like finding the average length of the bases and then multiplying by how tall the shape is. This is different from shapes like rectangles, where you just multiply length times width because all sides are straight and even. To understand why this works, picture cutting the trapezoid in half diagonally and flipping one part to make a rectangle. When you do this, the shape becomes a rectangle with a width that is the average of the two bases. The height stays the same. This visual helps you see why taking the average of the bases makes sense. It's like turning a slanted shape into a straight one, making the math easier. But things get more complicated when the sides are irregular or slanted at odd angles. You might need to use the Pythagorean theorem to find the height if it's not given. This involves working with right triangles inside the trapezoid, which adds extra steps. Unlike rectangles where height is obvious, here you have to do some extra calculations. Compared to other four-sided shapes, trapezoids seem more complex because of this need to find or understand the height and the averaging process. Rectangles and squares are simple because their sides are equal and right angles. Parallelograms are also straightforward with a simple base times height formula. But trapezoids requiring you to think about the two different bases and how they relate to the height. Knowing how to find the area of a trapezoid is useful in real life. Architects, engineers, and land surveyors often work with trapezoidal shapes because not everything is perfectly rectangular. Being able to break down the shape into simpler parts or use the formula correctly helps make sure calculations are accurate. So, the reason the formulas seem complicated is because they combine the lengths of two different sides, involve understanding the perpendicular height, and sometimes requiring extra steps to find that height. Visualizing the shape as half of a parallelogram or splitting it into triangles can make the process easier to understand. Once you see how the parts fit together, the formula becomes less intimidating and easier to remember.